All right, hi there. Today, for pre-calculus, I'm going to be covering how to apply the sum and difference formulas as well as the law of sines, and we're going to get a little bit into Heron's formula as well. All right, so a couple formulas on the side. I put them down. I like to put them down in the beginning so you guys can write them all down. Put them in your notes. The first one is law of sines, okay? And the law of sines is for any triangle, not just right triangles. And it's A over the sine of A equals B over the sine of B equals C over the sine of C, or those three fractions upside down. You either have the signs on the top of the fraction in the numerators or in the denominators. You don't want to have mix and match though and have, one sign in the denominator and one sign in the numerator. And that's for, any triangle. All right, and then there's Heron's formula, which is also for any triangle. And that's the area equals 1/2 AB sine of C, okay? And for that, I'm going to put this down here in red. You want side, angle, side, values, okay? Move this. Okay, I'll come back to that, but figured I'd put it in the notes. And then we also have these two formulas for the sum and difference formulas for sine and cosine. We went over these in the last video. Just remind if you're using the top here with the addition, then I'm using the addition there. And if I'm using the subtraction between the x and the y, then it's the subtraction between the sine x, cosine y, sine y, cosine x, okay? And the same thing for the cosine. You either use the top ones or the bottom ones. Plus, if it's cosine x plus y, then it's cosine x, cosine y minus cosine or sine x, sine y. Or if it's the other sign, you'll use the other signs at the bottom, okay? All right, so those are your formulas for this video, and getting going. All right, so first one, sine of u equals 3/4 in quadrant 2. Oh, and these values are for like the next three problems too, okay? And the sine, a cosine of v is negative 5/13 in quadrant 2, okay? So, let's see if we got any room over here. Not quite enough. So I'm going to draw these two out, all right? So let's do the sine one first over here. So it's in the second quadrant. It's up here like this. So this will be my u, all right, the reference angle, and sine is opposite over hypotenuse. Okay, sorry, that should have been a 5. Sine is 3/5. Please change that value that I had written as a 4, but it should have been a 5. It was a typo, which is what threw me off. All right, so sine is opposite over hypotenuse. 3 is the opposite. 5 is the hypotenuse. So I'm going to find the third side of that triangle. Okay, so I'm going to do Pythagorean theorem. Go 3 squared plus b squared equals 5 squared. And if you solve that out, you get 4 for b. Okay, so my missing side is 4. All right, so that's the first one. And next I'm going to do the 5/13 for the cosine. Once again, this is in the second quadrant. The difference here is that one's going to have a negative value, okay, because the cosine is negative. So here is, I should make that a v instead of trying to do a theta. That's v. And let's see, cosine is adjacent over hypotenuse, and that's negative along that axis for the x values, right? So they can make the 5 negative. And if I did the Pythagorean theorem here, you would get 12 for b. All right, so there's my values. Now, this is the formula. All right, the first problem is find the cosine of x minus y. Okay, so two typos already. Please change the u's and v's to x's and y's. Sine of x equals 3/5. Cosine of y equals negative 5/13. And I changed those values in there. This is just going to make it easier. Sorry, you can switch the value, keep them the same if you want, but when we get down here to x and y, you can switch that to u minus v's. Okay, so back to this. I know already from this formula, okay? I plug in the values for x and y into the difference formula, and I get cosine x, cosine y equals sine x, sine y. So now I'm going to take each one of these and go up to that triangle up there and figure out, what is the cosine of x? Well, the cosine of x is right up here. Cosine is adjacent over hypotenuse. That gives me 4/5. Next, what's the cosine of y? Cosine of y is negative 5/13. Adjacent over hypotenuse, right? Negative 5/13. Sine of x. Sine is opposite over hypotenuse, which is 3/5. And sine of y. Y is over here, so opposite over hypotenuse is 12/13. And this is looking pretty nice and easy. Now I just multiply the numerators together, multiply the denominators together. I got negative 20. 13 times 5 is 65. Plus 12 times 3 is 36 over 65. And I can add those two fractions together. Negative 20 plus positive 36 is 16 over 65. And there's my answer. Not my day. I made a quick mistake here. This one right here, the cosine of x, that should be negative because we're in the second quadrant. So that should be a negative 4/5, which means when I multiply them together, I get positive 20. And when I add them together, that'll give me not 16 because you don't subtract them, but you get 56. Okay, thank you. Sorry for the mistakes. Number 2, x minus y, sine of x minus y. So my sine difference formula is sine of x minus y equals sine of x cosine of y minus sine of x cosine of y. Okay, so I can take these same diagrams here. In fact, I'm going to copy and paste, cut and paste these. Take this. That ain't gonna work. Over here, and all right, so sine of x, sine of x. Sine is opposite over hypotenuse, is 3/5. Cosine of y is adjacent over hypotenuse, which is negative 5/13, minus sine of x. Sine of x is opposite over hypotenuse, which is 3/5. I had that written down wrong. Sine of y, cosine of x goes at the end. So sine of y is 12/13. Cosine of x is 4/5, but that's negative because it's in the second quadrant. And then if I multiply these together, I get negative 15 over 65 minus, actually that'll be a plus because there'll be a subtraction and a negative, 48 over 65. And if I add those together, I get 33 over 65. Okay, so I've now done the first two parts here, okay? And there's a nifty trick I'm going to do for this last one where it says the tangent. the tangent of x minus y, rather than using the tangent formula. These are exactly the same. If you look back at number 1 and 2, I have the cosine of x minus y, and I have the sine of x minus y. They're the same things inside of the parentheses. And tangent, one of the definitions of tangent is sine divided by cosine. So I know already that the sine of x minus y is 33/65. And the cosine, I already figured out, is 56/65. So if I simply divide those two, I don't have to go do all that work, and I don't have to work with the tangent formula either. So you just flip and multiply, okay? 33/65 times, I flip this one, 65 goes on the top, 56 goes on the bottom, and then these 65s cancel, and I'm left with 33/56, and there's my answer. Okay, and that was pretty nice and smooth. I like that. All right, number 4, identify or verify the identity, So cosine of theta minus 3 pi over 2 equals negative sine over 2. All right, so I'm going to take the harder side, which is the left side. That's a subtraction. So I use the formula here, the difference formula for cosine, and I got cosine of theta equals times cosine 3 pi over 2 plus sine theta over sine 3 pi over 2. So this is all like unit circle kind of stuff, This is the coordinates 1, 0. This is 0, 1. This is -1, 0. This is 0, -1. And remember, the sine is the y coordinate and the cosine is the x coordinate. So if I'm looking, for example, the cosine of 3 pi over 2, 3 pi over 2 is 270 degrees, cosine's the x, that's 0. 0 times anything is 0, so that whole thing cancels out. Sine of 3 pi over 2 is -1. So I got the sine of theta times -1 plus 0. So that's the same as the negative sine of theta. If you remember back to your formulas, with the sine of negative theta, you can bring the negative outside. Or just move the -1 to the front rather in this case. Okay, just right in the front. And there we go. And I'm done. Okay. Number 5. Same type of problem, except it's got the sine of 3 pi over 2 minus x. So if I break this one down, do my quick unit circle again. This is 1, 0, 0, 1. The unit circle, -1, 0, and 0, -1. All right, so sine of 3 pi over 2, that's the y coordinate of 270. Which is -1, times the cosine of x, minus the sine of x, times the cosine of 3 pi over 2, which is 0. So that whole 0 times sine of x is 0, okay, which means I've got negative cosine of x is all that's left there, and I'm done, because that's what I was looking to prove from up here, okay? Those are pretty good. I like those. Anything with that, zeros and ones are always nice. All right, this one, solve the equation between 0 and 2 pi for the cosine of pi plus x plus the cosine of 3 pi over 2 minus x. Okay, so this has really got two things, all right? So I did it in two different colors here. Here's this one, which is in blue, and then the other one is in purple, okay? So I just did the sum and difference formulas for the cosine there, okay? Now let's take a look at what we got. The cosine of pi, remember, once again, we're going back to this unit circle here with the zeros and the ones. So the cosine of pi is halfway around, and cosine's the x, so that's -1. Sine of pi is 0, so that's 0 times sine of x cancels out. Next I got cosine of 3 pi over 2, that's 270 degrees is 3 pi over 2, so that's 3/4 of the way around. The x coordinate there is 0 times the cosine of x Sine of 3 pi over 2 is the y-coordinate of 270, which is -1 times the sine of x. So this whole thing is supposed to cancel out eventually, huh? So this is gone, that's gone. Okay, so I'm here. So let's see, I got negative cosine of x minus sine of x, and I'm solving this equals 0, which means if I bring the sine to the right side by adding sine of x to both sides, I got negative cosine of x equals sine of x. Now I can divide by the cosine of x. And sine divided by cosine, we already said that during this class. That's the tangent. And I'm left with a -1. Okay, so tangent equals -1. That's tangent being 1. That's 45, 45, 90 triangle. So that's 1, 1 square root of 2, which means tangent 45 is pi over 4. And tangent is negative here in the second quadrant and here in the negative in the fourth quadrant. So what are those two angles? We're about to find those out. If this is pi over 4, that means I got 3 pi over 4, and going almost all the way around will be not 8 pi over 4, but one less, which is 7 pi over 4, and those are my two answers. Okay, so next, law of sines. Here's some new stuff. Solve the triangle. So with this one, I'm putting the sides on the top here. Solve the triangle means they want all the sides and all the angles. The easiest thing to do first is to find the missing angle, okay? Remember that a triangle adds up to 180. So if I take the two sides, the 35 plus 42, add them together and subtract from 180, you can find the missing angle. And if I do that one, I find quickly that angle C is 103 degrees. Okay, so I got that down. Now I need the side, okay? They gave me one side. I have to have an angle and a side opposite it, okay? For the law of sines. That's the way I like it. To have a side and an angle opposite it. And one more piece of information, one more value. So, often law of sines and cosines go together, and how do you choose which is which? Well, I'm looking for that side and the angle being opposite each other and having both values, okay? Which means in this case, I see here, those two are across from each other and I have both of them. So I can plug those in. So I can go 12 over the sine of 35 equals, let's find side B first, okay? So here's B, and sine of the angle opposite B, which is 42. So those go together, those go together. You guys with me? And I don't have to use side C. You only use two of those three fractions usually, okay? So the next thing I do is I cross multiply and solve, okay? So I got 12 times the sine of 42 equals B times the sine of 35. And believe it or not, depending on how you like to do this, you can divide both sides by the sine of 35 right here, and I can get an answer that's what I call calculator ready. So B equals 12 sine of 42 over the sine of 35. And when you punch that all in your calculator, you gotta have a calculator for this, you will find out that B is going to be 14. Okay. Do not do Pythagorean theorem. That's not a right triangle. You can't use Pythagorean theorem. Okay. So I have to do law of sines again to find the missing side, which is going to be, what am I missing? C. So side C, new color, green. Over the sine of the angle opposite C, we said C was 103 degrees, equals, I can use that same A over the sine of angle A, which was the 35. So you can reuse some of those values in the fraction there. So I got C times the sine of 35 when I cross multiply equals 12 times the sine of 103, which means if I divide, I get C equals 12 times the sine of 103 over the sine of 35. Okay, and then you can punch that into your calculator, and you'll find out that C should be about 20.4. That's my answer. Okay, good. Next one, number 8. Number 8, let's solve for x. Okay, so in order for me to solve for x, I need the angle across from it. Okay, I see I have a value and an angle and a side opposite where I know both of them, which is great. But I need, one more piece of information. It's got to be either the I can't use the 45. I'm going to use the 45 though to find angle A. All right. So if I add 30 plus 45 together, I can find out my angle A. Okay. Which in this case is going to be 105. Now I can set up my law of sines. Okay, I can go x over the sine of 105 equals 32 over the sine of 30. Okay, I hope that makes sense. Use the side and the angle opposite it in each of the ratios. Okay, now I'm just going to cross multiply and solve. Okay, so I got x times the sine of 30 equals 32 times the sine of 105. Notice how I don't multiply that 105 and 32 together. Okay. All right, and if you solve this out, you will find out that x is 61.8. 61.8 for x there. Okay, and that's it. Okay, now Heron's formula. This is the formula that we use to find the area of a triangle. Okay, and it doesn't have to be a right triangle. It can be any triangle. All right, so that's a nice thing. Now here's what I said. You really need to be side angle side values. If you remember back to your geometry days, there's a way we proved triangles congruent was called side angle side, and you need the two sides and then the angle in between it. So you really need that setup for Heron's formula. So like this is the right setup. See how it's the two sides and then this is the included angle, the angle in between those two sides. You need that setup for Heron. So sometimes if you don't have that, you can use law of sines to find some values to get that setup. Okay. So anyway, this one is already set up for it. Okay, so in this formula, I can make this C, and if this is side A, then this is if that's angle A, then 90 is side A. So this one sets up. You can label it that way too if you like. So A is the area, equals 1/2 Side A is the 90, side B is the 52, and the sine, the 102 degrees, is my angle, okay? And then you're straight punching it into your calculator, right? Make sure, you know, that you multiply those three numbers together and then multiply by a sine of 102, all right? So if you do this correctly in your calculator, you should get that the area is 2,288.9, okay? Yep, that's it. Okay, let's try another one. Find the area of the triangle. So with these, it can be, sometimes kids look at it and they're like, oh my God, I don't know what to do. Well, whenever you have these, draw a diagram, do yourself a favor. Okay, here's angle A, here's angle B, here's angle C, and remember side B is opposite. And if you have troubles about which one's sides and which one's angles, just look for the degrees. So this is 55.75, side B is opposite angle B, side C is 80, and there we go, we're all set. So I would like you to try this right now. From there, now that I've set it up nicely for you, okay? And see if you can find out what the area of the triangle is using Heron's formula. So hit pause and come back in a second and I'll show you the answer. Welcome back. The answer to the U try number 8 should have been 1,653.2. If you did that correctly. 1/2 times 50 times 80 times the sine of 55.75. Okay. Next, solve the triangle. So let's draw a triangle first. A, B, C. Angle A is 58. Side A is 20. Side C is 10. Okay, so I am going to be going after angle C first, okay? Now I always like my missing variables go on top, but it doesn't really matter. So I'm going sine of C over 10. The big one that's real important for me to pick out is I have to use that one because that's the one that's got the side and the angle across from each other. And I know both of the values. So this is my first ratio, okay? Now I'm going to cross multiply this, and when I do that I get 10 times the sine of 58 equals 20 times the sine of C, okay? Now you can divide by 20, I get 10 sine of 58 divided by 20 equals the sine of C. Now what's different about this one is I'm missing the angle, which means I'm going to turn that whole thing into a decimal, okay? And then I'm going to do the inverse sine. So when I punch that whole thing in to my calculator, so when I do all that, I get 0.4240 equals the sine of C. So then I do the inverse sine of 0.4240, and I'll get my answer of 25.1. If you're not getting that, make sure your calculator is in degrees, okay? So 25.1 is angle C. So if I do add up the side, the two angles and subtract from 180, I'll get angle B is going to be 96.9. Okay. The last thing I got to do is I got to find the missing side, which is B. Okay. So I know this is 96. So I'm going B over 96.9, the sine of 96.9. Equals, and I can reuse that angle A, side A. So 20 is the side, sine of 58. Cross multiply and solve. If you do all that out, you should get b equals 3.4. And that's that. Okay. Last problem, and it's a you try. So I want you, and I made it a little easier. It's not a whole solve the triangle thing. It's just find the measure of angle B. So they gave you a couple values here. So if you get stuck, you draw a triangle. Here's angle A, angle B, angle C. So here's your 110. Side A is opposite angle A, and side B is opposite angle B. And they want you to find that angle. Okay, so once you hit pause, see if you can solve it. It's a lot like the last problem. And come back and check your answer. Hey, there's your answer is angle B should have been 18.2 if you solve that out correctly. Okay? And that's all I got for today. Thank you very much. Have a great night. If you have any questions, please bring them to class. Thank you. Bye-bye.